My name is Přemysl Janík and I'm a material and process engineer at the European Space Agency.
My name is Laurence Levent. I'm a space material and environmental testing engineer at the European Space Agency.
BepiColombo will be the first Europe's mission to Mercury. It is a joint mission between ESA and JAXA, Japanese Aerospace Exploration Agency. When the spacecraft arrives at Mercury's orbit in 2025, it will face extremely harsh conditions. The temperatures as low as -190 degrees Celsius in excess of 450 degrees C. It will also be exposed to strong ultraviolet radiation and electron and proton fluxes for the entire mission duration. Over that time, we need to rely on the performance of all materials and components used on a spacecraft.
The ESA Material and Electrical Component Laboratory was approached by the mission team BepiColombo to test and improve the stability of the coating foreseen for the high-gain antenna. The antenna had to be manufactured to extremely high accuracy. Any overheating or reduction of its performance will result to a high risk for the mission and results for a loss of data in case we cannot communicate with the spacecraft. The ESTEC STAR2 facility is a facility where we can expose simultaneously samples to UV intensity and radiation particles, simulating the harmful part of the sun and measuring at the same time the performance of the material as if we were in space. For the antenna, it was important for us to test its ability to reflect the incoming radiation and emit the heat. As we refer to the solar absorptance and high thermal emittance, these two properties help us to regulate the temperature of the antenna, which we aim to keep below 450 degrees Celsius.
After the initial test, we identified two prospective ceramic white coatings which showed quite good resistance to high temperatures and UV radiation. These coatings were later tuned with a specifically doped coating so we could reduce the radio interference.
Of the two samples, we use a range of methods to achieve samples with different thicknesses and different adhesion strengths. For us, the challenge was the risk of cracking of the coating, and for that we had to analyze the surface with sophisticated electron microscope. Then after, the samples were mounted on a sample plate and exposed to UV radiation.
Visual inspection after UV radiation exposure showed we faced a major challenge. We noted very strong discoloration effects on the first set of exposed samples. We had to carefully analyze these samples to understand what was the root cause of the darkening.
We also checked the adhesion of the coating to assess whether the surface layer will peel away after high-intensity UV exposure by applying a tape test. And after improvement, our final coating shows sufficient adhesion strength.
With our industrial partners, we introduced several improvements to the coating process so we could significantly increase its performance over thousands of simulated testing hours. In the end, we developed the coating which will not only survive the conditions around Mercury, but it will maintain its performance over targeted range of our mission. We are really looking forward to the launch of BepiColombo in the near future, so we can demonstrate how our team has contributed to the first Europe's mission to Mercury.